In our example so far, the models have been about distributions with just two categories: purple flowers or white, black jurors or not. But in many situations, distributions involve multiple categories, and to assess models about such distributions, all we have to do is slightly extend what we have done in the case where there are just two categories. And we're going to do that in the context of an example about jury selection in Alameda County, California. In 2010, the American Civil Liberties Union of Northern California studied the composition of jury pools in Alameda County and presented a report about disparities between the population of eligible jurors and the people who actually were in the pools. And what we're going to do is look at their data, which is kindly provided in their report, and try to assess whether these disparities could have happened just by chance. To do so, it's important to understand how juries are selected. In Alameda County, there is a population of eligible jurors, and there are well-defined criteria for eligibility. For example, you have to be 18 years old or more, you have to be a U.S. citizen, there are conditions on English language comprehension, you should not have served in a jury in the past 12 months, and so on and so forth. There's a number of conditions. And from this eligible population, the final jury is selected. The chance comes in the middle of this process. First, from a practical perspective, somebody has to have a list of eligible residents. That's a task in itself, but let's assume somebody has that. It is from this list that a panel of jurors is selected. That panel is typically much larger than the jury itself. It could have 100 people. And it is the panel that must be selected at random from the eligible population. It's this choice, the panel, that has to be random. The actual jury that hears the case is selected from the panel, but that choice is not random at all. Lawyers from both sides, the judge, can select or exclude people from the panel to serve on the ultimate jury based on the specifics of the case. It's the panel that is supposed to be selected at random. What do we mean by supposed to be? It's a matter of law. California's Code of Civil Procedure has a section that describes what should happen. All persons selected for jury service, that is the panel, shall be selected at random from a representative cross-section of the population. What we are going to do is look at the ACLU's data and consider the questions that might arise. The table jury contains the data that were provided in the report. There are 5 ethnicities. Well, other is a composite. The eligible column contains the proportion of eligible jurors in each of the 5 categories. The panels contains the proportion in the panels. Let me explain the plural here. The ACLU considered panels in multiple trials. All of those were supposed to be selected at random from the eligible population. So all of the panels together were supposed to be a giant random sample picked from this distribution. There were 1,453 people in all in these panels. At a first glance, if you look at this distribution of eligible jurors and the distribution of the panels, they don't look the same. It's always easier to visualize, so let's just do that. We'll draw a bar chart of these distributions of ethnicities. The blue chart represents the eligible population and the gold chart, the people on the panels. And you can see there is some difference between the two. They're not the same, but they are also somewhat similar. For example, in this category, they're almost exactly the same. In the Asian ethnicity category, there are a higher proportion on the panels than there are in the eligible population. Conversely, in the black ethnicity category, there are a higher population of eligible jurors than were on the panels. There's a little bit of give or take. The question is, what leads to the give or take? Could it just be chance? If you select at random from here, could you get a distribution that looks like the gold one? After all, if you select at random from a distribution, you don't expect to get exactly the same proportions as in the underlying distribution. There's quite some variation, as you have seen. The question arises as to this variation that we are observing here, could it have happened due to chance? That is, could it have been that the panels were in fact selected at random from here and came out to look like this, like the gold bar graph, just by chance?